Hello, everyone. Welcome to today's webinar titled Preparing the Substrate, Flat, Dry, Easy. I'm Jim Olson with the NTCA, National Tile Contractors Association. I want to welcome you and thank you for taking time out of your busy day today to attend today's webinar sponsored by LATICRETE. Before I introduce today's speakers, I want to remind you that during your webinar, you will be muted. Please use the questions area on your computer to type in your questions, and we'll answer those at the end of this presentation. If the audio on your computer is poor, call the number on the invite of this webinar and listen on your phone. I want to remind you that all NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after these webinars are presented. This will give you easy access to watch and or share all current and past programs at your convenience. All right, today we're really lucky. We have two great presenters. Our first presenter I'm going to introduce is Elvis Torres. He's a product manager with LATICRETE International, overseeing the concrete and substrate preparation division of products inclusive of NXT, SuperCap, and L&M brands. He's responsible for the overall performance, strategic vision, new product development roadmap, the entire product lifestyle of his product line. With over 12 years of experience, Elvis has specialized in substrate preparation and flooring systems, developing and launching products within North America and internationally. He holds a BS in Concrete Industry Management and Finance from the New Jersey Institute of Technology. Our second presenter, Joe Rizzo, is the Director of Sales for Concrete and Substrate Preparation at LATICRETE International. He leads the efforts of the US and Canadian teams in the sales of surface preparation, moisture control, and the SuperCap network of mobile pump trucks for high volume, rapid delivery of self-leveling underlayments and overlays. Joe graduated from NYU Polytech University with a BS in chemical engineering. His perspective on flooring and concrete has been honed by the contractors and architects that he has had the privilege of working with over 25 years. I want to welcome both of you and very excited to see your programs. Thank you.
Thank you for having us, Jim.
Jim, thank you very much, and thank you to the NTCA for all the fine and valuable work that you guys do for the industry. I also want to thank Jim, who kindly understood that I have a face for radio, so you won't be seeing me on the webcam. You'll be seeing just the presentation. You don't know how lucky you are. I think we can jump right in and begin, right?
That sounds like a plan, Joe.
Right. Okay, so we jump right in with some technical stuff, and I've got to let you in on a little bit of a secret, and some of you probably already know this, that substrate preparation, making concrete in a condition that is able to receive a final floor, is nowhere near as sexy as a tile installation with all the beauty and the aesthetics that are involved in that. So what we hope at best is to give you a peek behind the curtain so that you can see what goes into getting a surface, a substrate that is ready to receive that beautiful floor and ensure that it is beautiful. So there are different measurements of flatness and deviation from flatness when it comes to the installation of tile. ANSI 108 says very clearly that 1/4 inch is the maximum allowable deviation from flat when you take a 10-foot straight edge that is perfectly straight. So what that means is if I take my 10-foot straight edge, put it on the concrete, and look underneath that straight edge, at no point in those 10 feet should I see more than a 1/4 inch dip of light. The second stipulation is that within 1 foot, there can't be a deviation of more than a 1/16 of an inch. And these are all measured from the high point. LFT, or large format tile, as most of you know, is a tile that is defined within any edge that is greater than 15 inches. So if you have a 15-inch by 6-inch piece of tile or 8-inch piece of tile, it is still considered a large format tile. The rules for that change in terms of how much is the allowable maximum deviation, still as per ANSI, which is the American National Standards Institute 108. That goes to 1/8 inch in 10 feet and 1/16 inch in 2 feet. So you can see it is a significantly more stringent requirement of flatness for a large format tile. Now I'm going to show you a little bit of a contrast. Concrete is defined as being flat enough for most placements as a floor flatness level of 25. That is defined as a 1/4 inch in 10 feet. That is not specified by an architect or an industry association. It is specified by a structural engineer because the purpose of concrete in a building primarily is to be the structural element that does the heavy lifting, literally. The concerns of flatness for a floor are secondary and often something that needs to be reconciled. So you can see that even in a perfectly designed new construction, we have a deviation from what LFT, large format tile, would require that has twice the strictness in tolerances. And we're creating immediately a situation where there's going to be an expected, I don't want to say argument, but certainly a discussion about what level of flatness that concrete needs to be brought to. Next slide, please, Elvis. Okay, I'm not going to dwell on this too much, but it gives you a graph, and the graph is there as a visual representation more than anything else with specific data points. Division 3, which is the division in a specification that deals with concrete written by structural engineers, FF of 25, rough correspondence of 1/4 inch and 10 maximum allowable deviation. Large format tile, twice as strict, 1/8 of an inch. So you can definitely see the correlation there. Next slide, please. Tiles are getting bigger and bigger. We are aspiring to seeing these ever expansive applications of large panels, gauge porcelain tile panels that are anything larger than 36 by 36 inches. We've seen some of these be over 10 feet in a single dimension. There's a new ANSI standard which details the unique installation and transportation methods. These panels are more delicate, more difficult, more expensive, and most of all, they require a very flat substrate in order to be placed without lippage and without straying from where they're supposed to be. The good news is the NTCA sponsors training programs on how to deal with these types of panels. The other thing that's going on is grout lines are getting smaller, so we really have nowhere to hide, either vertically or horizontally. We don't have anywhere to hide if our substrate is not flat. Next slide, please. The requirements for the substrate have to be stricter. The only way you can get proper tile adhesive coverage and avoid lippage is to have them flatter. And something which is new for us in the tile industry is all of a sudden a parameter that wasn't necessarily as important previously has now become or is becoming more important in the tile world. We're talking about tiles or panels that are relatively impermeable. We're talking about grout lines that are thinner. So we've always had to worry about moisture carrying efflorescence through the grout line, but now we have to worry, particularly in a slab that's on grade, and by that I mean it's on the ground. There's always a possibility that there's moisture with some pressure pushing up through. Previously in a ceramic tile or a weaker porcelain tile, that moisture could get through the tile or through the grout line. Now that is no longer possible. So in this new age of very large tile, very large panels, very small grout joints, we are looking at the requirement of dryness underneath the tile as well as flatness. Next slide, please. Luckily, the NTCA and TCNA give clear-cut recommendations. They say you can use a self-leveling underlayment, a bonded or unbonded mortar bed, grinding to take down the high spots. There's one that I get a real kick out of, which is to increase the steel reinforcement to the cross-sectional area. If you have the influence and you're early enough on that project that you can influence the civil structural engineer on how much rebar they're putting in concrete, man, oh man, you are really good at your job and valuable to the industry. The recommended specification installation method for self-leveling and bonding or unbonded will get you to the required flatness for a large format tile. Thin set or medium bed mortar is not allowed to be used for truing or leveling. Do you remember when we all said we'll make up for it in the mortar? These installations do not allow for us to make up for it in the mortar. That's why you use a mud bed or even more simply an application of self-leveling underlayment. Next, please. So here's the steps to a proper surface if we were taking it one step at a time. First of all, know it's required of you. What is the flatness or level required for the application? And we will talk about the difference between flatness and level. When you're bidding, that is important, so we will touch on that specifically. Test the cohesion of the concrete slab. Very often that's not necessary. However, there are questionable substrates, and there are ways that we can take a stand and say, no, I, as a responsible tile installer, as a responsible flooring installer, do not find, Mr. GC, that the concrete slab that you're giving me is strong enough. Do we always have to do that? No, but it does come up. Then we determine the allowable moisture. We mitigate if necessary, and by mitigate, I mean provide a method to act as a barrier that stops the moisture from hitting the tile. We prepare our substrate concrete or our substrate wood. Most of the time here in this presentation, we're talking about concrete, but many of these things, with the exception of moisture mitigation, also apply to you having a wood substrate. By the way, sometimes you'll hear the term substrate and subfloor used interchangeably. They're not. Subfloor is the entire structure of the floor underneath the final floor. So that includes the joists, the plywood, the concrete, and everything else that goes with a structural support. The substrate is very simply the surface on which we will be adhering our tile application to. Next step, once we've got that all under control, we mark and measure the elevations that are in our floor, because you can't tell what is flat if you don't know it. Sure, there will always be the people that are particularly good at being able to walk a floor and saying this part's off and that part's off. But the truth is, we need to know quantitatively how good or bad of a situation we are in, particularly in a large commercial application, and especially when we're talking about LFT or gauge porcelain. And finally, we have our proper products, our self-leveling, our mud beds, depending on which direction we're going in, and those need to be mixed, pumped, and poured, and that's how we get to a proper surface. So one thing to note about this before moving off this slide is that your moisture mitigation, if it is necessary, which, like I said before, may not be in the majority of the cases, but it can be, you do your mitigation first, and it goes directly on top of your substrate, and your self-leveling and your other flooring goes over the top of the mitigation. We don't self-level and then mitigate, we mitigate and then self-level. Next, please. I mentioned before how we have to determine the suitability of our substrate. By the way, where this becomes particularly important is when we're talking about a renovation where we may be dealing with generations worth of patching that's on our substrate, or previous layers of glue, or previous layers of thin set or mortar, right? So what we do is we use an apparatus similar to what's shown there, and we get the bond strength. For most applications, the tensile pull, and what we are doing is we are pulling in tension. If we get 100 psi or greater, and we've got documentation that addresses these, so these are not numbers that you have to memorize. I'm just kind of letting you know what the quantitative aspect of it. But if we have greater than 100 psi in tensile pull on our substrate, we are good to go as far as the integrity of the substrate. That doesn't mean we don't have to roughen it up and profile it. We may or may not, but certainly we are comfortable that we are on a suitable substrate. And then if we happen to be doing a slab on grade application with very large tile or panels with thin grout lines, we should check for the moisture to see. By the way, epoxy grout, totally impermeable. Non-porous tile, almost totally impermeable. And again, the good news is our industry friends and heroes at NTCA give us comprehensive lists of what those parameters and conditions are. Next slide, please. Okay, preparing the substrate. It always needs to be clean and free from foreign materials. No coatings, no sealers, and practically no adhesives. Old layers of cement-based materials can be acceptable if they meet the parameters of 100 psi bonded to the rest of the concrete substrate. The other thing that we absolutely need to do is prime. If we're going to use a self-leveling underlayment, priming is necessary for bonding and outgassing. I'm not going to get too deep into that on this slide because my good friend Elvis is going to be addressing that further down the show. What you see in that bottom picture numbered 1 through 10 are sample profiles of concrete substrate preparation levels, CSP. You have a CSP from 1 through 10. Some products do require mechanical profiling. So a very typical CSP level that you will see for many cement products, but also many epoxy products and other resinous types of products, are a concrete substrate preparation level of 3. Basically, it feels like a sandy texture, like you're rubbing your hand over a piece of sandpaper. Some products, some self-leveling underlayments, some patches, certainly thin sets, don't require mechanical profiling, but some do. So make sure that you've read the manufacturer's direction and you're doing the appropriate thing for the product that you're putting down on your substrate prior to your tile installation. Next slide, please. Okay, where does the moisture come from? Just so you understand. Moisture can come from concrete itself. Concrete has a parameter that we call the water to cementitious materials ratio. Basically, at a ratio by weight of 0.3 of water to cement and other cementitious materials, that's what you need to hydrate cement, either in concrete or in any other material that contains cement. And cement and concrete and mortars do not dry. They hydrate. The water reacts with the cement. And the ideal ratio usually is a 0.3. So 30% water by weight, 70% cement by weight. Anything over than that is water of convenience. So that water wants to come out. And this is particularly more important for moisture sensitive flooring, like vinyl resilient flooring, wood, carpeting, not as much in tile when we're talking about that water of convenience coming up off of a slab that's above grade. However, it can be a cause of concern. The other water that you need to be concerned about when the slab is on the ground, even though there's often a 6 or more poly thickness, vapor barrier, those can be compromised. So you may have water coming up through the ground, and that is constant, and that may have an even more urgent requirement for using some type of moisture mitigation. Next slide, please. Okay. Here, what we're looking at is a resinous system. It's an epoxy. They are easily applied. They two steps. They go down. They get poured out, spread out with a pre-measured squeegee or gauge rake, more appropriately, and then flattened out with by back rolling. And that will give you something. There are a number of brands that provide absolute moisture protection if that is necessary. And I won't get into the quantities or the specifications for this, other than to say that F3010 gives a very comprehensive set of requirements of what these moisture mitigation systems are supposed to do. Next slide, please. Okay, here's an opportunity for tile contractors. We all have our specialties, and flooring installers, tile installers, and so forth sometimes like to keep into their own lane for a very simple reason, that we have our specialists that are best at doing what they do. So you may not want to directly get into substrate preparation. The good news about that is that you could look at it as another income revenue stream and decide to self-perform. And manufacturers like us can help out with training and next steps, not only just the material pitch and material advertisement, but how to pour, how to pump, what's the equipment that's necessary. Everything that's an all-encompassing package can be shown to a contractor that wants to expand their capabilities, and with some practice can probably self-perform quite well. However, there are those contractors that don't want to do that, but still want to have the benefit of being able to bid on a job that has substrate preparation. There is a large number of self-leveling underlayment application contractors that only do that, and you can subcontract or partner with them. And that's something, those are connections, those are relationships that we may be able to help you develop so that you do get to put in a bid. Some of our largest contractors have relationships with companies that do that, and they have successful subcontractor relationships or even JV relationships. Next slide, please. Okay. So we're looking at a floor here that's neither flat nor level. And I wanted to point out the differences because it is important to know not only what your conditions are, but the reason that that's important is to know what you're bidding on. I was recently on a project in Florida that could have been specified as the floor needs to be flat. However, the specification was written that the concrete slabs needed to be level with the benchmark. So I am going to ask you to use your imagination for a little thought experiment. Picture a sheet of pristine paper that's in front of you that has not been crinkled. That paper is flat. It doesn't have waviness. It doesn't have bumps in it. It is simply flat. And that's how you can imagine a concrete slab. But that doesn't mean that it's level. If you take one end of that piece of paper and you lift it up an inch, you now have a concrete slab that is flat but not level. Now, sometimes that may be what we require, right? We may want a slope to drain, and we want a flat slab that's not level. But sometimes we need both. So keep in mind that getting a floor level requires measurements using a device that measures elevations in the floor. Next slide, please. I might have said next slab instead of next slide. We're looking at two different methods of measuring elevation. On the right, you see a traditional laser. There's a rotating laser head that projects a 360-degree laser beam, and standing across from that operator on the laser portion is someone else holding a story pole, and we can measure elevation relative to being marked. That is probably the most common way of doing an elevation measurement. A different way is the picture on the left. We call it a NIV comp or a master level, and essentially it's a self-contained unit. And some people will compare it to old-fashioned water levels. It's not a water level, but it is a liquid level. It measures elevation differences based on where that pole is sitting and gives you a digital reading. It's a little bit of a different approach, but it works very well. And most flooring and tile contractors find those easier to use than laser levels. Next slide, please. Okay, Elvis, if you could run that video. This is, again, a job site in Florida where a mud bed is being used. It is a good method in limited geographies with contractors that have a labor force that is both large and available and skilled and inexpensive in putting down a mud bed, but it is not as easy as self-leveling. There are a few times that we want to use a mud bed instead of a self-leveling product. If you're sloping, a mud bed may be the way to go. If you have a natural stone that is not rectified, you want to do a wet set possibly, for the simple reason that you can get that floor as flat can be, get the substrate as flat can be with a mud bed. However, if there's waviness and bumpiness on the bottom of your natural stone, you may want to use a wet set method. So I do bring that up. It is a valid method, although as technology gets better with the self-leveling underlayments, we are seeing it not as much and not as prevalent in large areas in structures where we need flatness or level. Next slide, please. Okay, a self-leveling underlayment. First of all, let me start by saying self-leveling is a marketing term, and that has been an issue of much discussion in this industry. No, I hate to say it, there is no microchip in every bag, nor is there any artificial intelligence in every bag that tells the material where to find its level. These are highly flowable cement-based materials that are as strong as concrete usually, that can be placed at a fraction of an inch or up to multiple inches to give us the flatness or the level that we require. We generally pump or pour to the elevations that we have measured that we were shown before. New generation self-leveling products, self-leveling underlayments are more flowable than ever before, and they actually do approach self-flattening. The way we determine our floor flatness is by measuring the elevations. The closer the distance between the elevation measuring, the higher degree of flatness that we can get with this new generation of self-leveling underlayments. Application and material methods can be used to achieve very flat, super flat floors. Flowable hydraulic cement underlayment / self-leveling underlayment is defined in ANSI 118.16 and 108.21. So we have characteristics and guidelines to help us in our path. Next slide, please. All right. You're done with me, as well you should be. Mr. Torres, it's all yours.
No, you're never done, Joe. No worries. I got lucky. I'm going to be showing you a bunch of videos so I can wake everyone up. So to Joe's point.
Thanks, pal.
No worry about it, Joe. No, but always great to hear from Joe. And don't worry, we didn't get rid of him yet. But I wanted to just show you a couple different videos here. As Joe mentioned, this is material that does a lot of the work for you, but you have to get it there across the finish line. And the nice thing about self-leveling is that a lot of manufacturers have different water ratios. So what does that do? Those different water ratios allow you to control the application that you're primarily in. It's so hard to write one like the instructions for one application that fits everything. There's so many different nuances and different scenarios on a project that just needs to be attended to very specifically. So again, having that flexibility of the water gives you the ability to just go around and adjust it to what you need. So you can see that the video on your left is a little bit more of a thicker consistency, while the video on your right, you can see is much more fluid. And again, that's just all degrees of what you adjust with water. Now remember, the more water you add to any cementitious product, typically you're going to have a little bit of lower performance when it comes to like compressive strength and everything like that. So, but again, as long as you're within the specification of the manufacturer that you're using, you should be just fine. And another thing I would like to note in this slide is that you can see that the image on the left shows you a small quadrant. These were mock-ups that were actually done. Me and Joe were present at one of these projects, and I mean, this is a quite smaller one. We obviously would prefer a much larger one, but sometimes this is necessary when you're doing a specific floor finish or setup. It makes everyone understand on the project, and even the customer at the end of the day, what they're going to be receiving and what's everything going to look like. What is that system? What's the sandwich of all the different products, whether it be repair, moisture mitigation, self-leveling, your tile, whatever it may be that you're placing on top. It's just always great to do that. Just very good. So then sometimes you have floors that are actually pretty flat, but just need a little bit of a moderate repair. So that's where you're going to have patches and skims that come into play. Now, these are hand applied products that have different consistencies. Again, there's so many different products out there that offer many different performances. Skims are just very, very popular in this space. Typically used to flatten concrete. As you can see on the right hand side, you see some of those indentations in concrete, and that individual is flattening those with a skim. On the left-hand side, as you just saw as that video played, this was OSB. Very popular to use skim on top of a oriented strand board, just because of the fact that it's all multiple glued pieces of wood. And when you're laying down a finish, not so much primarily an issue with tile and stone, but when you start getting into the vinyls and other finishes that are very, very thin, you could sometimes see some of the telegraphing of whether it be deviations in your, let's say that you weren't as handy with a trowel and you left a little bit of a notch on that floor, you would actually see that telegraph through the final finish. And same thing with the wood and everything like that. Also, a lot of the adhesives require a cement-based substrate to adhere to. So that's also a big reason why, for example, on top of wood, you would be flattening that floor, leveling it, skimming it with a patch. Again, giving that good base, that good foundation for the glues to adhere to. But again, not that much of an issue when it comes to tile and stone. But overall, the more you're going to kind of skim and fill in with these products, the more you'll be able to, save on the more expensive items in the build. Joe mentioned that we will be touching upon this. So priming, extremely, I think I said extremely important when it comes to self-leveling. It's actually a step that many individuals fail to actually think about really when they're doing a self-leveling underlayment. Why do you want to do this? Well, you're doing this because the fact that you're going on top of concrete. Now, these, even before I even touch upon that, these self-leveling underlayments and these type of products have a lot of polymer built into it. So the good thing is that you have a lot of ruggedness, a good product to start off with that you're going to give you a good sense of confidence of bonding. But the primer promotes those attributes, and on top of that, it just acts as a barrier to stop water from, because you're mixing these self-levelers with water. The concrete's going to absorb that water like a sponge if you don't have a primer to stop that from happening. So what you're going to have is potentially cracks starting, because again, you're drying out that material that you're pouring on top of the concrete, which also can cause delamination. So, I mean, the worst thing you can have is, you know, once you have all your floor and everything completed and you start walking on it and you start feeling that you're walking on a hollow space, not a very good feeling, as in, you know, tear outs and everything like that, and going back in the process, losing time, so on and so forth, right? Time is money. So again, priming is extremely important. Now, there's many various primers on the market. There's some primers are hard to bond surfaces. So for instance, maybe you don't need that much of a CSP, as Joe was mentioning earlier, typically are requiring around a 3. Sometimes you can go from a 0 to even 1 and not do such an aggressive profile and use a primer to make up for that. There are other ones that need a more of a profile openness to allow the primer to be absorbed into the surface. So again, reading the manufacturer's instructions is always important, and again, knowing what you're kind of walking into as well. You know, are there adhesives in there before that needed to be completely removed? And again, if you're going to be priming, we would surely hope that you will be leveling very soon after, just because of the fact that the more you leave things open on a job site, the more they can get dirty, right? I mean, there's so many times where, you know, sometimes applications are the sheetrockers come in and they start, you know, doing the walls, and then you have all this dust that falls onto the surface. Again, these are all bond breakers that could potentially, you know, cause an issue for you in the background. So if you're going to be priming, great practice would be is to self-level as soon as possible, just to avoid any potential issues. Pour stops. Now, this is very important when it comes to doing deeper applications, deeper fills. As you saw some of the images that Joe was actually going through, you'll see many of those images have pour stops in them. This is just a way to allow you to control the space. So obviously, if you're doing let's say for an example, a 2-inch pour, by the time you start pouring material, it's going to start flowing and it's going to get away from you, and you're never going to be able to kind of build that thickness. It's just going to kind of keep on flowing. So this kind of allows you just to kind of break up the space, do it in different steps, and again, control the pour. It just becomes very helpful and we even have videos further in the presentation to kind of show you this. But I mean, you can control the space. Once these products cure very quickly as well. You know, hours versus, you know, other technologies, which could be even days and weeks. So as the product is, by the time you're maybe on one side of the space where you originally started, depending on how large it is, you know, and maybe you're drying already, so you can start removing these forms and start filling in the gaps between each of your pores, and finally doing a quick kiss coat of the self-leveler on top, which again, we have some really great videos at the end of this. But again, this is a great way to just maneuver around the space. That you can see those little plastic notches on the floor. Those are actually allow you to kind of gauge how much material you need to put on the floor to make it level. So quite a large height there, probably about 2 inches. So this is just a way to make that all work together. Now, there's many very different options when it comes to self-leveling. It's amazing how the technology just keeps on evolving. And nowadays, there's lightweight options, and there's these lightweight self-levelers and even other materials available, which overall gives you the capability of going to structures that may be compromised by weight. Maybe they're older structures, maybe they weren't structurally designed to not knowing that you're going to be actually, wow, these floors are actually going to be taking on quite a bit more weight than what we thought. So the nice thing is that there is technology out there that allows you to get these spaces level, flat, whatever obviously the end goal is. And also there's a safety factor to it. I mean, you know, we want people who are in our industry to last a very long time. There's so much wear and tear on our bodies nowadays. So again, even a safety aspect of it, of weight, and also eliminating sand, which obviously helps when it comes to silicosis and everything like that. And these are just great charts to kind of show you the different weights compared on the product that you're using, and also the technology. As I mentioned, you know, you're really doing this because of the fact of you have load bearing issues in buildings. I mean, there was a project that Joe and myself were on that we pumped up roughly about 8 million pounds into a building worth of weight of self-leveling. Obviously multiple stories and different elevations throughout the space. That goes to show you how much self-leveling can go into a building. So again, always a good option to have on. Usually lightweight self-levelers are poured at a very thick thickness, just because of the fact that hence why we're kind of running into issues when it comes to weight. But your normal self-leveling underlayments are going to be around 120 pounds per cubic foot. And when you get down to the lighter weights, they can range from anywhere from 65 to 70. There's some really great performing lightweight self-levelers from, I wonder who, Joe.
Yeah,
but
right.
Yeah.
What things, if I could, sorry.
Oh, absolutely.
We've all seen the advent, and you all probably have more experience using lightweight mortars and thin sets and so forth, and how much easier it is on the body. So those same principles apply to self-leveling, and dare I say, maybe even more so because of the very large quantities that we may be pouring, because we're not going a fraction of an inch thick. Like Elvis said, when we're using these, it's because they're being placed thickly. If that's a word, is thickly a word? I don't know. But there's, you're talking about tons of material being moved. So if you're mixing by hand or in a mixing station, which you'll see a little bit later, it makes all the difference in the world. Take those benefits that you've seen in your tile setting materials and apply those to an even larger extent to these self-level materials.
No, absolutely. I mean, well said. And again, I mean, there was applications that we've actually partaked in due to the fact that there was actually a confined space. You couldn't even get freight elevators or any type of material down, and using carts. So actually carrying it was the only way in. And it's really nice to carry a 25-pound bag versus normal weighted material. So many benefits. And it's just always another tool in the arsenal. It's just always nice to know what you have at your fingertips, depending again on the situation, what a project may be throwing at you. Now we love to talk. I love this slide. It just kind of goes to show you the span of work that you can achieve with self-leveling products, and we like to talk to them in different stages. So you may be mixing 1 or 2 bags, which again, these 15-gallon units are quite popular in probably smaller residential applications or maybe tight spaces, but very popular. Then I would say one of the most used methods is the mixing station. So you can potentially have 2 or 3 of these mixing stations set up in a certain location, and you have carts that are running back and forth. We call them runners sometimes on the job site, and they are filled up with material, and they take off to where the material is being applied, and these mixing stations start all over again, mixing material. Now, 3 to 4 bags are typically what these mixing stations can handle. And again, moving up to a larger stage, which is actually a pump, which would require more power, a power source. So typically a generator or having an electrician come onto the job site, the hardwire certain panels just to give you enough voltage to run those machines. But again, great. They will move as fast as the individuals who are filling them up with material. There's blades on the top of that grate, which when you slam a bag onto, it cuts the bag in half. And again, you dump the material in there. They'll mix it. There's a rotor stator in there that just keeps on turning, takes that powder, mixes it with the water, and then pushes it up a pipe, which again, we have some great videos that kind of show that. And finally, there are just some manufacturers out there that have large machinery that are capable of leveling stories, thousands, tens of thousands of square feet in a day. And these are just, quite large applications. And judging by the space that you have, the timing that you have, when the space is going to be opened up, allows you to kind of gauge of where you're going to use, what type of angle you're going to use to level or flatten that space. And this is just a nice video of a mixing station being used. Now, when you're typically actually using these, it's great to pour into the mix that you previously have done. It just makes it much easier for the individual who's flattening the self-leveling underlayment to continue that process nice, smooth. If you're throwing that quite a bit far away from all the larger material that has already been poured, it's just kind of you're kind of pushing it back into that mix. The less that you can touch, it, the better it's going to do. Your better your finish is going to be. The worst thing you could do is just keep on agitating the material, which again, there's heavier composites such as sand, and you're just forcing that material further down the mix, and you could potentially, you know, give yourself a little bit of a soft, chalky surface because you're just making the water rise up. So the less you can touch it, the better. There's processes and methods of laying down this material, and as I mentioned before, you know, you're going to need larger voltage to kind of run some of this machinery. Mixing stations kind of offer you the ability to avoid that, but you're going to be a little bit slower. So again, different angles for different methods and means. So as I was just explaining about having either the individual who's going to be smoothing that surface, so you want to break that surface tension. Once you pour it, there might be a little bit of memory, if you will, of the self-leveler once you pour it down. So always passing on top of it with either a spiked roller, porcupine roller, also known as, or a smoothing blade is always a great. These are the two main tools that are used. I would say probably a smoother being a little bit more of a popular tool, just because porcupine rollers, even if they're great, once you get into thicker pours, they become a little bit more difficult, and also cleaning. As you can probably know, visiting job sites are sometimes not the most clean locations. So some of these tools, they get away from you, and then they become quite useless if they're not maintained. But both great methods of planning a floor. I would say when it comes to you know, overlays and stuff like that, again, this is obviously primarily focused on tile and stone, but if you're doing those, definitely stay away from a porcupine or spiked roller, as you could probably get some telegraphing of that spiked roller in your final finish. But both great tools, very easy, both very easy to use, and you're not going to put really any pressure on these tools as you're moving it through the self-leveler. You're just glancing the top or just gently pushing the roller back and forth. Now, sometimes you want to, if you want to, depending on the space, we always would say recommend doing elevation checks and making sure, you know, how much material you're going to need, because staging is quite important. The worst thing you can do is to be in the middle of a pour and run out of material, and then you're kind of running and sprinting to your local distributor if they hopefully even have the material in stock, so on and so forth. So it's always great to level to see what elevation you need, but there are elevation and gauge rakes, which are great, nifty tools. Now, we have a tendency to kind of favor the gauge rake versus a with the cam gauges on the side versus the rakes in the middle, and that's because of one reason. Those rakes are set by these two locking pins, and if you're quite aggressive with that rake, the blue one, actually you can't really see it just because it's on there, but those two little needles coming up, that's actually it's measured. If you bang that against the ground, you have a tendency to mess up that calibration. So you may go there with a measuring tape and measure half an inch. If you slam that on there, you may have taken off a little bit, an eighth or 16th, and then you're not at the site. So the one on the left, that cam gauge, you see that like star cam gauge at the end, those are fixed. So it doesn't matter what angle you hold it, up, down, you know, it's just pretty much going to always give you that depth that you're looking for. So again, favored. They're more expensive, hence why you probably see a little bit more of the rakes in the field. But again, nice little tip there for you of what makes the difference between these two different tools. But they pretty much help you just set the depth. So you have, you know, you can set them anywhere from an eighth, a quarter, half an inch, so on and so forth. So this is great. I mean, we talked about pour stops and everything and controlling your pour. This was a great video kind of showing this in this feature in action. The high speed of it, so you can see that allows the individuals to fill up one location, stop, go back, and fill up the other ones. And you can see that the ones all the way on the further left are already dry, and that individual's removing the form, getting ready for the second, you can say, kiss coat of the self-leveler.
So this was a 5,000 square foot wide open retail space that had elevation differences that were all over the place and significant. One of the best reasons to use a pour stop, those separations, is that even if you're pumping fast, so here we were pumping at 400 bags an hour, maybe even a little bit more. Even if you're pumping fast, when you're talking about a wide open space that's many thousands of square feet, the pump can't keep up with the elevation that's required, because the material is flowable enough that it wants to keep on spreading and spreading and spreading. You need to build up 2 inches, but it keeps going away from you and you can't control it. That's where the pour stop comes in. It allows you to build up your thickness and your elevation without losing control and being unable to keep up with it.
And this is the second stage. So you can see now as all that dries, it's just very well communication with each other, timing, and you can see that it's a nice flow motion of just work being done.
And in this particular application, this was a neat installation in that as they ended the first thick 2-inch layer, the other side of the room was ready that they could walk on it and pump material over the top. So we make materials that'll go up to 3 inches or even 4 inches. But my recommendation is always, if you're pouring that thick, even if the material has the capability of building up that thick with no potential compromise of the material properties, at that thickness, it's easier to put a slight thin coat over the top to get that glass-like, lake-like finish than trying to control and smooth out a 2 or 3 inch pour.
Yeah, yes, I mean, that's true. And also, I mean, depending on, again, situation, maybe you can't pour all that amount of material in one shot. So there's also lifts that could be done. So let's say you have a material that maxes out at 2 inches, but you have to go up to 4. You know, you can pour down that 2 inches, again, redo priming procedures, and then continue with another 2 inches on top. So again, just another way of looking at things. And ultimately, we're trying to make the surface of the moon and getting you a nice flat leveled surface for tile and stone.
Yeah, not much more to be said about going from point A to point C and actually being able to do it successfully. And by the way, it's worth mentioning, it is easier to install over a flat substrate by far than a substrate which is kind of flat or kind of level. Studies have been done, contractors have commented, it just goes much faster. Even if you don't have the requirements for a very high level of flatness, it's easier to spread out your tile adhesive mortar, it's easier to place your tiles, everything becomes easier and faster going over a flat substrate.
And just for those who are wondering, that is actually the same project. So that floor on the top left is what it looked like on the bottom once the application was complete. So
yes, it is
a very nice before and after, and quite an aggressive situation. But overall, I think, you know, me and Joe thank everyone for being on this webinar. We greatly appreciate always the opportunities of doing this, and we hope, please let us know if you have any questions.
Yes,
I just have to real quickly say, great presentation, lots of knowledge and lots of education being presented there, and I really like it. We do have some questions here. If you guys are ready, I'm gonna read them off to you as we go, okay?
yes,
so the first question is, do you need a primer on concrete slab if you need to self-level?
Yes.
Yes, and practically always.
Yes.
I was going to say yes and yes.
Yes, and yes, it helps the bond, and it helps keep the concrete, that big rigid sponge that wants to put air into your application of self-leveling. It stops that from happening as well. So yes and yes.
Yeah, and there's different methods and means. I mean, we have methods where there's a water drop tests are typically done, where you can put water on top of the concrete, depending on how that concrete absorbs that water, gives you an idea of what maybe type of primer you're going to have to go forward with, or what type of prep. So there's nice little methods and tests that could be easily done with a water bottle on the job site to kind of give you an idea of what direction to head in.
Great. All right. When you use the brakes, Do those cold joints need special attention in the finish?
If you
Go
know,
ahead.
I'll jump first, Joe, and I know I know you'll go right, but if attacked at a certain time, as you saw in that one video, by the time they were getting to the end and pouring, and the individual was removing those stops, no, it was such soon after, the material still kind of curing. If you get it to the point of so quickly afterwards, you know, again, these products have high polymer content, and it's not going to be necessary again if it's very soon after.
So, and that addresses the layer to layer, but the block to block might be also part of what you're asking, Jim. So it all depends on the size of the application, believe it or not. In a large application, you have some time to maybe remove the form, but typically, no, there's not a lot of special care that needs to be done with these cold joints, right? You're bonded to the concrete. There's no space between them. You do fill up when you remove your formwork. Now, you saw in one of those, they use dimensional lumber, right? So you have a 2-inch gap, which when that dimensional lumber is removed, you fill that 2-inch gap. If assuming it's a 2x4, it's actually 1 3/4 inches. You fill that with self-leveling, and you span that. In the last 2 slides that we saw, they used angles, which stayed in the application itself, and the angles were precisely measured to be underneath the level of the highest pour, so you no longer saw them. So no, there's no real special thing that needs to be done to address those.
Yep, nothing special, but the thicker ones, bigger ones, you do have to fill that gap, definitely. That's great.
Yeah. I mean, if you remove a 2x4 that's been standing on its side, like I said, you've got a 1 3/4 inch gap, and then you go back and you fill it in.
I'm just repeating it so that we make sure everybody hears it. I caught you, Joseph. Thank you. Hey, several self-leveling products require cool or cold water. In climates where it's triple digits in the summer, how important is it to use cold water during the mixing?
That's a great question. We do a lot of work in triple digit environment. Cool water will absolutely, positively help to a greater degree than you would think. And because if you look at the materials by weight, water is the least amount of weight, yet because it blends in so completely and because it reacts, it has a catalytic type of effect. So cool water in triple digits, and that could be ice water, right, will absolutely help. Other things to fight temperature. Don't keep material in sunlight. Sounds obvious, but it's amazing how often it is not done. Work early in the morning. So in a lot of areas in the U.S., you know, you're talking Arizona. I always thought Florida was one of the most challenging places to work until I did a job in Arizona where it was 114 degrees, where we should have absolutely not been pouring. But tenting, cold water, material preconditioning, and working in the wee hours of the night instead of at high noon make all the difference in the world. Also, some manufacturers have the capability of providing you a material that may be a little bit slower for hot weather applications.
I want to make sure everyone understands too that also is required in thin set, grouts, all of those mixed. You don't want to mix them in that hot weather with warm water, hot water. I mean, you're just creating a time frame situation for yourself and a real problem. So cool water and hot temperatures, tenting, all of that, very important. Yes, thank you, Joseph. I appreciate that. Do you need to honor the control joints in the concrete up through the levelers? I think you kind of answered this already, but if there's anything you want to add to that.
If it's a control joint, not really. If it's an expansion joint, yes. The leveler itself will follow what's going on in the substrate. So if we're doing, let's say, an overlay instead of an underlayment, in other words, we're pouring something that's meant to be pretty. We're not doing a tile installation, but we're doing a pretty overlay that's going to get ground and polished. You want to give it joints. If we're doing an underlayment, a slight width, so a hairline crack in an underlayment does nothing to compromise the application. It does not hurt it as long as we are fully bonded to our substrate.
Cool. All right. Are you able to use a primer and the material for the mitigation of moisture at the same time? And they're not saying at the same time together, but on the same floor.
Yes. And when we're using, let's say, a moisture mitigation system that is an epoxy, that epoxy goes directly onto our substrate. It does not need a primer. That material cures, and then there are two options. If you use a standard epoxy moisture mitigation system, you then use a primer that's specially made to go over non-porous surfaces. And Jim, you're gonna have to forgive me. I'm gonna mention a brand name of a product of ours because so many contractors know Prime and Bond. But Prime and Bond can be used directly over an epoxy without a sand broadcast. Now, if you use a moisture mitigation system of the newest type of technology, you may not need a primer. If for example, you use this particular type of epoxy moisture mitigation that is made to be used as primerless, if you do your pour of your self-leveling or your thin set within a certain number of hours, you may not need to use primer. So I'm not sure, was that the question you were asking, or did I answer?
That's good, Joseph. That's good, Joe.
Yeah, and just one thing to note too, I know we've mentioned a lot of epoxy-based moisture mitigation systems here on the presentation. Technology is also evolving, and a lot of one-component moisture mitigation systems are coming out to kind of rival epoxy-based. You know, there's allergies, people are becoming allergic to epoxies, obviously. The mixing of the different components and the more greener side of things. So just to let everyone know that there are different options, one components, two components, and to what Joe mentioned, some of them have built-in primers, some do not. And again, you may not want the built-in primer if you're not going to be going on top of that floor in a quickly fashion. So again, just knowing the tools that you have available.
So Elvis exercised his right as a product manager to let the cat out of the bag about maybe a particular manufacturer that we know and love coming out with a really, really good single component moisture mitigation system that is not epoxy. See, I don't get to do that, but he's the product manager.
Excellent. All right, we got more. So the next is for a commercial project where you're removing vinyl tile and there's adhesive down. And what sort of prep work do you need to do if the vinyl was applied over on-grade slab and you want to pour over that?
Well, I mean, there's different options you can do, again, based on the product they're using. You can remove it completely by going over it with machinery, either shot blasting or grinder, and remove it completely. There's other we like one of the products mentioned earlier. Sometimes you just have to remove the adhesive to the point that it's translucent, and you can prime right over it. So a lot of primers are used that are hard to bond. Primers could be used, and not that much mechanical prep would be necessary. So different ways of looking at it. Some people feel 100% I need to remove everything. Also depending on what the material is made of. May change this, but you have to either completely remove it with machinery or roughly remove it and prime over it with higher performing primers.
That makes sense. Better primer.
If you expose the vinyl adhesive and you see that it's black, or you see that it's obviously not water-based, please be sure to ask your general contractor to give you reassurances that it is not hot mastic. In other words, that it is not asbestos. Not informally, not, it should be fine. But be super careful that you're not being asked to do an asbestos abatement that you don't even know that you're doing.
Yeah,
So,
I agree with that. Very important. Excellent. What happens if you use thin set to skim coat instead of patch?
I don't get the commission. Other than that, it works just fine.
Good. Okay, next. That was easy. I like that one. What about a perimeter joint around the leveler? Recommended?
No, not necessarily. So in certain types of self-leveling materials, primarily those that are gypsum, you have to do perimeter isolation. There's a reason for that. Gypsum, unlike cement-based materials, which is what we're talking about here, does not hydrate in the same way that a cement product does. Remember before I talked about hydration, it actually dries, and it dries much, much slower. So what you end up having is moisture from the gypsum that can wick into the drywall and cause mold. Also, the product may not be dimensionally stable, i.e. it may shrink, so it needs or expand, and it might need some room to be isolated from the wall. Most current technology, cement-based self-leveling products, and with certainty, I can only speak about ours, do not require, we have done hundreds of millions of square feet of self-leveling without perimeter isolation.
All right. And it looks like our last question, guys. Will underlayment primer and the SLU product bond to leftover hardwood glue residue on rough basement slab?
I would say that's kind of some, again, one of those primers, higher performing primers that can bond to applications where there might be leftover residue or anything like that. Now, remember, you're trying to remove that glue as flat as possible, because depending on your floor finish that you're using, it may telegraph through if you're leaving any ridges or anything like that. But again, you can remove as much as possible, use a high performing primer that can bond to smooth substrates, and you should be okay.
I think this is a great question to end with, guys. And the reason I'm saying that is for the audience, it's really important to check with your manufacturer's representative, their technical line, talk to them if you have these kind of questions. They'll talk about each product. They'll actually make recommendations for you. Please, always follow manufacturer's recommendations over anything else, and make sure you check with them if you have questions, definitely. All right, guys, Elvis, Joseph, fantastic, great job. I hope you guys have a great rest of the week. Attendees, thank you so much for being here. I think you learned a lot. There was a lot offered. Look forward to our invite coming out for our April 3rd webinar, and hope to see all of you at coverings. Take care.
We'll see you guys there. Bye-bye.
Bye-bye.
Bye now.